Hi everyone. In my today's session, I'm going to explain about the repository pattern. Okay. So this repository pattern is associated with the solid principles, last principle called dependency inversion. Okay. So what this principle says is implementation should depend on abstractions, but abstractions should never depend on implementations. Okay. And repository is such a pattern, as its name itself says, it's a repository. It stores something, it keeps something, okay, and allows external words to query with that storage basically. So what is this repository? A repository basically allows you to query the underlying data store, okay, or the data which you would like to access or which you would like to save some data into. Okay, this is a repository, this is a storage. Now this pattern basically abstracts out the underlying storage. Okay, a repository can be pointing to a SQL server database, it can be pointing to a in-memory database, okay, or it can be pointing to any kind of storage. Okay, it may be Azure storage account. Okay, but this pattern basically abstracts out the underlying storage and provides a uniform interface to query with it. Okay, so with that is said, let's have a look at this repository pattern. So I have written a simple contract for this repository. Okay, so if you see this contract, public interface I repository of T. Okay, so basically this particular contract is going to deal with the type T, where that T should inherit from a base entity class. Okay, so if I speak in terms of SQL Server technology, and that's where I'm going to explain about, because my underlying data store is SQL Server database, or it can be any database product. There is no specific requirement that it should be MS SQL Server. Okay, so I am explaining this with respect to the underlying data store as a database management system. So now I'm speaking with respect to MS SQL Server and the ORM framework called Entity Framework Core. Okay, so in this scenario, what I have done is, for my repository is going to deal with the type T. Okay, and that T should inherit from base entity. And if I go to this base entity, can you see? Okay, it provides some base properties or attributes for your entity. Okay, like ID, a primary key. Okay, every entity should be identified by its unique ID or identifier, we can say. That's why we must have a ID for that. Okay, and then these remaining four properties, that's created by created date, updated by updated date, basically I make use of them for tracking purposes or in order to make this entity a traceable entity. Okay, so whenever I create a new record, I'm going to fill this created by and created date columns or attributes, you can say. And whenever I update an entity, I'm basically going to fill this updated by updated date column. This basically allows you to have a auditing in your database management system or in your data access layer. So that's a brief introduction for auditing also. So all these things should be considered while designing your repository pattern or your entity layer, I can say, okay, or data access layer, I can say. Okay, so this is what my base entity. So whatever entity inherits from this base entity, they will inherit all these five properties. Okay, so this is how my database the database access layer design is associated with. Now I will go to the concrete implementation. Okay, look at my iRepository class. It is interface. This is basically a plain C# interface file. Okay, it is not at all pointing to any of your underlying data store technologies like entity framework, okay, like Gemfire, GFE, in-memory database libraries, nothing. It's a plain C# interface. Okay guys, so very simple. What all operations it has? Okay, it has a get operation. Provided if you provide entity's primary key, that is ID, then it will return you that entity. Okay, that is task of T. So I have written my entity layer, or I can say the DAL layer, asynchronous way. Okay, I want all some of yeah, I want some of my operations to be done in asynchronous manner, but again the choice is yours, and depending on your requirements you can make them synchronous also by not making use of the asynchronous APIs provided by the frameworks. Okay, so in my case, I'm getting an entity by its ID. I'm getting all the entities which are available in the database table. Okay. And I'm adding an entity to my underlying database management system. I'm adding a range of or a list of entities to my database table. I'm updating an entity, some of its attributes. Okay. And I'm deleting an entity. And the most important method being query. Okay. Now let's go to the concrete implementation of this repository pattern. Okay, this is my contract. Okay, so you may be thinking what this query and what the type it is returning. Basically I queryable of T. I will soon explain what is the significance of using this type when it comes to entity framework core. Okay, ORM framework provided by Microsoft in order to deal with your underlying database management system. Okay, so let's go to the concrete implementation. Now you can see that what is the underlying uh, database management system I am using by this namespace reference or the library reference. Okay, I am making use of Microsoft Entity Framework Core. The moment you see this particular uh, library being used over here, you can be assured that my underlying database store is basically a database management system. Okay, so I'm making use of a DBMS, okay, in order to store my data and get my data. Now, in order to facilitate the communication between that database management system and my software product or software application, I'm making use of this ORM tool. Okay, so you can go through the MSDN documentation from Entity Framework Core. It's a very vast documentation and you can get a brief idea about it. Okay, so now I will go through the implementation. Okay, so what I am doing here basically, look here. Okay, public class repository of T. Okay, implements the interface I repository of T, where T is basically inheriting from the base entity. Okay, look at this signature. Okay, same constraint. Okay, same generic constraint I am putting here also basically. Okay, so in any way this T should be inheriting from the base entity. Then I am keeping a DB context object reference basically in my repository class, that is private read only DB context. A DB context is a unit of work pattern. I will explain about it briefly in my next video, but for the time being, understand that a DB context object in entity framework always represents a connection to the database. Okay, and also it represents a unit of work pattern basically, which is used to deal with the underlying data stores. Well, that's being said, also I'm keeping a field called DB set of T. Okay, in entity framework, whenever we deal with database tables, all that communication or all that querying happens through a class called DB set. Okay, and DB set accepts an entity. Okay, so if I give here an entity called user, then basically I'm dealing with the table in the database called user through this DB set class. Okay, you can go through the detailed documentation about these classes and you will find very useful information in MSDN. Okay, but my idea here is to today explain only the repository pattern. Okay, so I'm going to concentrate over here. So what I'm doing, I'm getting a context object from the dependency injection. Okay, and I'm setting to my context, and also I'm extracting the db set class called my entities, that is context or set of T, whatever type I pass here. Okay, now I am providing implementation for all the methods I had specified in my contract. Okay, very simple. Okay, the first one, get all, which returns I queryable of T. So basically you will come up with scenario where you need to return all the objects in your database table. Okay, all the records in your database table. This will usually happen when you are populating a drop down. Okay, okay, for example, you are populating countries drop down. Okay, for example, you are populating the states drop down. Okay, in such scenarios, in very rare cases, you need to filter it, but most of the time you need to provide all the available records in that master table. Okay, so in such scenarios, implement a method called get all, something like this. Okay, so what it does, so underscore entities, which is a DB set of T, has a implementation for .ask variable. Okay, I'm going to create a video on ask variable, and I will explain why this method is most important uh, whenever we use entity framework core for creating our DAL layer. Okay, so I'm calling the underscore entities dot ask variable, and then I'm calling dot as no tracking. Okay, so basically what this ask variable method does is it returns a I queryable equivalent of your entity, or I queryable equivalent of your type basically, or your entity type. Okay, and what is the use of this collection basically? As queryable basically returns a collection kind of. If you go through its documentation, see, this is a convenient method to help with the disambiguation of extension methods, same names. Okay, forget about this. This ask variable basically allow you to build your expressions. Okay, around your LINQ queries. Okay, basically I queryable allows you to construct queries into LINQ technology. Okay, in language integrated query. Okay, so one of the most important use of ask variable is that it don't immediately load all your database records, database table records into your memory. No, it won't load it. It does the deferred execution or lazy execution. What it does is first it will construct the expression tree, it will construct the SQL statement for your underlying database. Okay, then it executes whatever filters you have put, it executes, and then it loads the record into your memory. That's why ask variable is very useful and very important method whenever you deal with entity framework. Okay, and then I'm calling dot as no tracking method because I'm doing just a get operation. I don't want to do any modification with them. I'm just returning a list of entities to my client, or from a web API basically. In such scenarios, make use of this as no tracking method. Okay, so whenever you make use of as no tracking method, entity framework will not track your entities. Okay, because tracking adds cost. Okay, your entity framework DB context class object basically has to track all your entities for all additions, modifications, deletions, everything. Now if your need is to return a list of entities, that's it, no modification, no addition, nothing, then make use of as no tracking. So this will increase the performance of your read operations basically. Okay, so if you see the documentation, it says that the change tracker will not track any of the entities that are returned from a LINQ query. If the entity instances are modified, this will not be detected by the change tracker, and db context.saving will not persist those changes to the database. Okay, so be aware of this. You can use this only when you want to read a set of DB records. Okay, but if you want to do any modifications, then you have to just call ask variable. That's enough. Don't call as no tracking. Okay, so get all does this operation for me. It simply returns a list of objects. Okay, so well, that is set. Now we will move on to the get method. Okay, so this is basically a asynchronous method. You can see the async keyword I have put here, and it receives the primary key of your database table. That is the ID or identifier of your database table. And what it does, the dbset class provides a method called find async, and this method basically finds an entity or a record in your database table using its primary key, that is ID. Okay, so that's what I'm making use of. Simply find async ID and configure await false. Okay, so I'm saying that configure await is nothing but a method which allows you to tell whether The execution of the asynchronous operation should continue on the thread which basically invoked this operation, or it should continue on whatever available thread uh, which has been used to perform this asynchronous operation. Okay, so I have configured it false. So whenever it calls find async method, and whenever it finds a new thread to perform this operation basically, so on that operation only the rest of the execution will continue. Okay, so that's it. This is the asynchronous version of the get. And then I have written for the add, pretty simple. Public async task of t, add t entity. If entity is not equal to null, see the tracking behavior. Entity dot created date equal to date time dot now I'm setting. So basically I'm setting the current timestamp to the correct created date, and then I am adding it to the DB set collection, okay, of that entity. And then the most important part is I am calling the underscore context dot save changes async. So till now whatever changes whatever entity you added to your DB set class, all those entities will be added to your database table as records. Okay, that's it from here. Add range, same as add method, but it adds a list of entities. Okay, so as you can see, db set class also provides a method called add range, and you pass an array or list of entities and it will save it to the underlying database table. Okay, so simply call underscore context or save changes async, and yes, it will save those records to the database table. Update, same thing. I'm setting the update date here. Okay, entity dot update date equal to date time dot now. Okay, even I can set the entity dot updated by also. Okay, for that I have to have that user's email ID or Azure object ID if it's on Azure. Okay, or if it has any kind of identifier or email ID kind of, you can pass it a service. You can inject a service into this repository, and yes, you can set that. Or before calling this method itself, you can set that value, and you can also set this updated date and pass it to the repository, and repository will simply does the operation of updating such entities or adding such entities. So here it is simply attaching the entity. Okay, see, attaching means basically the entity framework will start tracking this entity now. Okay, and then what we are doing, we are underscore context dot entry of entity dot state equal to, we are setting it to modified. Okay, and then we are calling the save changes async. So this will save whatever updations we apply to this entity to the database table. Okay, same as the delete, just call the db set, that is underscore entities dot remove, and pass the entity and call the underscore context dot save changes. It will delete that record from the database. And now comes the most important part, the public I queryable of t query. Okay, which returns a I queryable implementation of your underlying db set class, or you can say a list of records in your database table. Okay, so what is the use of this I queryable type is that you can construct complex queries using this particular type or a collection type. And advantage of using I queryable is that the moment you call as queryable, okay, it doesn't load all your database records into your memory. Okay, it simply constructs a expression tree. With respect to that expression tree, it will construct the SQL statements and then executes it on your SQL server, and then gets the record into your memory. So when you receive the records in your memory, basically they are all filtered. Okay, you are not loading entire DB records into your memory. Okay, so that's the advantage why people make use of as queryable in entity framework. Okay, so ideally this is what a repository pattern should look like. I have explained with respect to entity framework core with underlying database management system, but you can have different kinds of underlying storages. Okay, so this is how the pattern can be implemented and used. Okay, this is efficient, First of all, you are making use of asynchronous operations, okay, and also you are making use of as queryable, okay. So basically whenever you construct queries around your entities, okay, they they are not executed immediately because they are executed later. It's called lazy execution. First, whatever query you construct, it will read that query, okay, then it will break it into expression trees, then it will construct the SQL statement. That SQL statement will be executed on your SQL server, and then whatever record set is generated on SQL server, that will be returned to your program or to your software application. So this is how basically you are avoiding loading unnecessary records into your computer or your web server memory. Okay, so that's it for today. I hope you people understood how a repository pattern can be implemented and what is the best practices around there. Okay, I hope you people will make use of these practices in your day by day development. Thank you for listening and have a nice day.